Hello everyone. Today I'll teach about design and fabricate PCB for half adder, which is open-ended experiment in PCB design and fabrication lab for 5th semester electronics and communication engineering students. In this session we'll discuss about what are the system requirements or component required for this experiment. Introduction and circuit diagram of half adder. Procedure for design of PCB schematic and layout. In that we need to create schematic layout, generate a netlist, converts components to the modules, edit the PCB, generate Gerber file, and finally PCB fabrication process. For this experiment, the required components are IC 7408, IC 7486, AND gate and XOR gate, connectors and resistors, connecting wires, power supply, soldering gun, soldering wire, KiCad software for schematic layout and PCB layout design, copper clad printed photo paper A4 size, ferric chloride FeCl3, drilling machine, 1 mm drill bit, laser printer and iron box. As we know, an adder is a digital logic circuit in electronics that is used for addition of numbers. Basically, there are two types of adder. One is half adder and second one is full adder. We'll discuss about the half adder. The half adder adds two single binary digit A and B, and it has two output, sum and carry. In half adder there are two inputs and two outputs. Inputs are A and B and outputs are sum and carry. Consider the truth table. The inputs are A and B, outputs are sum and carry. If both the inputs are low, A is equal to 0 and B is equal to 0, the sum is 0 and carry is 0. If A is equal to 0 and B is equal to 1, the sum is high, that is sum is equal to 1 and carry is 0. A is equal to 1, B is equal to 0, then half adder generates sum is equal to 1 and carry is equal to 0. If both the inputs are high, A is equal to 1 and B is equal to 1, then sum is equal to 0 and carry is equal to 1. With the help of this truth table, the expression of sum is A bar B plus A B bar. That can be implemented by using the XOR gate A XOR B. That is nothing but A bar B plus A B bar. The carry is A and B. Carry is equal to AB. This is equal to A and B. The logic diagram of the half adder is the sum can be implemented by using A XOR B. That can be done by using the XOR gate 7486. A XOR B, that is sum. And carry is equal to A into B or A and B, that can be implemented by using IC 7408, that is A into B. A and B. The, the pin details of 7486 and 7408, these two ICs are 14 pin IC. Always the 7th pin is connected, to the ground, and 14th pin is connected to the VCC for both the IC. The 7486 and 7408 pin arrangement are similar. That is, the first pin is connected to the input and second pin is connected to the input and third pin is output. This is 2 input AND gate and also this is 2 input XOR gate. Fourth and fifth pin is connected to the input and sixth is connected to the output. For third AND gate, 10 and 9 is connected to the input and 8 is connected to the output. The 13th and 12th pin is connected to the input and output is connected to the 11th pin. In this, I am going to tell about design of PCB, schematic and layout on a computer by using KiCad. Let us do the schematic by using KiCad software. Go to Start, All Programs, select KiCad and click on KiCad. To create a new project, go to File, New Project. Give the project name or Experiment 8 folder, and the file format should be .pro. Select this, save. To design a schematic layout, click on Schematic Layout Editor. It will open eSchema Editor. In this editor, place a component of your project by using place symbol, click on editor. I required 7408 74LS08 for carry 74 ls 86 for some connectors for input, connectors for VCC, connector for ground, connectors for output, sum and carry. And select two registers, one for sum and one for carry. Rotate these any component by clicking on the component by pressing R. And also place power flag for ground, one for VCC. And select the source by using power port icon. This is connect all the components by using wire. and rename the component. After renaming, do the annotation. The annotation can be done by clicking Annotate Schematic Symbols. Click on Annotate. After that, do the ERC by using Electrical Rule Checker. Click on Run. After that, assign the footprints to the components which are used for this project. By clicking Assign Footprint to the components icon. See, these are the connector for ground, input, output, register R1 and R2, and V1 and V2, U1 and U2. For connector, select the footprints from the right side list. Here, connector, wire. If you want to view this footprint, you click on View Selected Footprint icon. For 3D view, it looks like this. Then just simply select it. Select this connector for all connectors. Okay. Now select the register footprints for the select this for both the register, and this can be selected the package. Go to package, select this. If you want to select socket, you can select it. Okay. Now save this schematic. Okay. After this, generate a netlist. Click on generate netlist icon. Click on generate netlist. Save this netlist in this folder with the file type .NET. After this, again check the error. If there is no error, then edit the PCB by clicking Run PCB New to Layout Printed Circuit Board icon. And read the netlist. Go to Tools, Load Netlist, read current netlist. Separate the components. Now these are the logical lines. Convert this into physical lines by using route tracks. A, connect this to some, seventh pin, for carry. After this connection, if you want to view the 3D, go to view and 3D viewer. This is a 3D viewer, 3D view of half adder. Take this print, this layout on a A4 size photo print. Go to file, print, click on print preview. After this, generate a Gerber file by clicking, go to file, click on plot, select file plot format as a Gerber and select folder. Now okay. View 3D, go to view, click on 3D viewer. This is the 3D view board. After this, take the print of this layout on a glossy A4 size photo paper for a fabrication. See, created a schematic layout by using eSchema, generated netlist, assigned footprints to the components, PCB layout of this project, 3D view, generated Gerber file. Now we'll do the fabrication. Take a single-sided PCB, remove the unwanted particles which is present on the copper clad by using scrubber. Take printed layout on A4 size photo paper, attach it on the copper clad. Next step is to transfer the heat on photo paper which is attached to the PCB board by using iron box. Next, after transferring heat about 2 to 3 minutes, or the image is completely transferred it on the copper clad of the board, then dip this copper clad into the water to remove the photo paper. Wait for 10 minutes and then remove the photo paper slowly. Next process is to remove the unwanted copper by using etching process. In this, we are going to use acid etching process. In this process, we are going to use ferric chloride and water solution that can be prepared by taking 1:3 ratio of FeCl3 and water. This can be used to remove unwanted copper. Once solution is prepared, dip the board in the solution, keep it for 1 hour. To remove the copper at the faster rate, shake the tray regularly. It will take 3 to 5 minutes to 1 hour to remove the unwanted copper. Once copper is get removed, except in the layout area of the board, pour acetone on the board. Clean it by using waste cloth, which removes ink or a toner on the copper trace. After removing the ink or a toner, then clean the copper trace on the board using scrubber. To remove unwanted chemicals. After this, using drilling machine, drill the mount points. Test the connectivity of the tracks by using multimeter. When tested OK, place and mount the components as per schematic diagram or a schematic layout and solder it properly. And finally, check and analyze the result by power up the circuit. For reference, use printed circuit boards by Walter Buschert, PCB by RS Kandapur, KiCad tutorial by using kicad-pcb.org/help/tutorials, PCB fabrication user guide, YouTube videos for PCB fabrication. Finally, we conclude that designed a PCB schematic and layout for open-ended experiment half adder using KiCad, electronic design automation tool, and its fabrication has been done. Thank you, one and all.